Hey everyone, my name is Eduardo, and this is a recording of our reading club at GitLab, the AI Reading Club, where we are reading through the book AI Engineering, and today by Chip Huyen, and today we're talking about the third chapter. Just as a note, this reading club already took place last week, but I forgot to hit record. It was a great session, lots of questions, lots of discussion. But since I cannot upload the recording because there's no recording, I might as well go through some of the summary of what was discussed. So the third chapter is called Evaluation Methodology, which is about how will you measure your LLM, or rather, how you will measure your AI app. How do you know that if it's working or not? This is a more theoretical chapter, which is quite good. But overall, you have three decision points on evaluation, just at a high level. And what you're trying to do in the end is deploy an app that helps users or your internal processes achieve some goal, right? This is why we're doing this kind of thing. We have to help our final consumer to achieve something. So, and for this, we choose a stock LLM, so a foundational model, whether it's Llama or I don't know, OpenAI models or whatever, and then we augment this LLM with our prompt, with the system prompt, or with retrieval context, or with additional context. So at each of these points, we can measure whether we are doing a good job or not, and maybe make better decisions to better help the user achieve their goals. So how do we go about this? What kind of techniques we can use about for evaluating at these levels? So I'll start by the end. So how do we evaluate the final app, and then the augmentation LLM, and then the LLM? Measuring, first of all, how do we measure if the deploy, if I don't, the user is achieving the final? How do you measure the final goal? Like I said, every AI app needs to serve a purpose, and we need to measure if it is achieving that purpose. And due to the nature of non-deterministic responses we have from AI apps, in this case, either because like temperature is high, generate a lot of responses, or retrieval returns different responses, it's hard to pinpoint deterministic if it's actually improving or not. So you need to do this by measuring the outcome, either by comparing multiple versions with A/B tests, either by using multi-arm bandits, or direct UX research, or get in contact with the users and see if it's improving or not. Sometimes this is hard because the changes might be very subtle, and a user cannot really pinpoint which one is better, if we actually improve the response or not. An A/B test can help in that scenario, but there's no silver bullet for this problem, and this is a larger discussion that measuring the impact of a policy in itself can have its own entire set of reading clubs. But this is how that's some of the techniques that could be used. The next step on the chain would be on the chain backwards. I mean, is like the first is augmenting the LLM. How do we measure if the modifications that we did to the LLM are good to the use case? This already, the final one measures the outcome, but this one is before we put this in production. How do we measure if the changes that we're making, like the guidance that we're adding to the LLM, is actually doing its job? So the author puts on a few techniques which are quite interesting. So the first one is functional correctness, which I think it's quite awesome, like really, is okay. If I generate a code response, for example, code completion, does it pass the test, some tests that I set up for that code? So as I am coding, as I am doing the task, I have a test that actually tests if that generation is correct or not. Another technique is comparison. So you generate multiple comparisons either from the stock LLM without adding your augmentation or a previous version, and then test how does this new response generated compare to the other ones. The downside is that this requires data sets to be built. Comparison test is you have a data set and then you compare the outputs of the LLM against that data set of golden answers. So for example, you can check how close they are to each other lexically or semantically, and measure the impact. But it's good that it's automated, but at the same time, it doesn't always correlate to an improved human perception of correctness. So you can use like a semantical approach to check if two answers are similar, but that doesn't always work. So that's why human in the loop can help on this. So you ask actual people to evaluate two answers and see if they rank one higher than the other, compare different models and so on and so forth, and that correlates better to what we want to aim in the end. And the last technique is AI as a judge, where you ask an AI model to test whether that answer that was given by your modifications, your augmented LLM, actually solve the problem or actually achieve what you're trying to achieve. The plus side is that it has high agreement with human evaluators. So some papers have analyzed this AI as a judge methodology, and if in general, if AI judge says it's good, a human will also say it's good. But it can also be costly. So you have to make a request to an AI. Human in the loop is also costly because you need to ask a human to do the evaluation. But again, it can be costly. It can be inconsistent. So if something changes on the model, it's a little bit complicated to identify where does that change happen, like if something changes in the evaluation. And it can also be hard to reproduce. It's non-deterministic. So for example, if you see a drop in score, is it because in the evaluations, is it because the model that you changed is actually doing worse, or is it just that the judge is being more, more tough on its evaluations? So it's hard to make a judgment on what you should do as a developer based on AI as a judge sometimes. And the author also puts a very important warning is to not trust any AI judge if you can't see the model and the prompt used for the judge, because you need to have control over the evaluation for your use case. Otherwise, you cannot know what will be your action. So like I said, if the score drops or improves, you don't know if it's because the model actually improved or if it's because the judge changed his behavior. So that's pretty important. It's pretty important to be consistent with that. And finally, the first step of the chain, and I think this is the most. Now you're getting from the end to the beginning. You get more and more theoretical. So the end is a lot user related, and here is a lot more academical. And I won't try to explain here each one of this terms, because there are a lot of videos on the internet that explain them quite well. So the first three terms, they try to measure how well the model, the LLM captures the underlying data it was trained on. So the probabilities of the text that were fed into it. But perplexity is a metric that's being used quite often for different models. And Bruno, another colleague, Bruno, put it very well, that is basically how perplexed the model is to the input is being given. So what's the likelihood? So it sees some prediction, and how likely is the next input next output to be given. So I like how the author also gives some interpretations or understandings, intuitions you can derive from perplexity. So the more uncertainty the model has in predicting what comes next, the higher the perplexity. That means the higher the context length, the lower the perplexity, because you're given a lot of context. The same way that if you give structured data, like for example HTML or a coding language, you can expect some structure. So the model needs to make less decisions on what to do next. But also how the vocabulary increases the complexity, because there are more things to be for the model to choose from. So that was it. That was my review of this chapter. Again, I'm sorry for not actually recording the discussion. There were a lot of different points that was very interesting. I will be sure to record next one. But thank you for watching.